Are we live? Yeah. So, hi everyone. Good morning to all of you. A very energetic good morning, everyone. How are you all? Hopefully, all of you are doing absolutely fantastic. This is your chemistry coach Sanjay sir, and we'll deal with one and only the most amazing topic of chemistry, organic chemistry, in our very ongoing and continuity series of organic chemistry. We have amines. So right after finishing aldehyde, ketone and carboxylic acid, the next chapter comes is amine, and right after that we'll have one more session on biomolecule very soon, probably on Tuesday, coming Tuesday we'll be having that session. And today we'll complete this small chapter of nitrogenous compound, specifically called as amines. So let us introduce amines first of all. What are amines? So guys, amines are the derivatives of ammonia. So what we do, by the way, so let us suppose we have a molecule of ammonia, and right after, in this molecule, if I remove one hydrogen and add one alkyl group, right? So this will become what? NH2R. This RNH2 group, this RNH2 is called as a primary amine or 1 degree amine. Amine with one alkyl group. Then if I do the same, like removing one hydrogen, adding one alkyl group, it will become R2NH, means one nitrogen atom over here is connected with two alkyl group. This is called as secondary or 2 degree amine. Do the same thing. Remove one hydrogen, add one alkyl group, it will give you R3N, called as the 3 degree or tertiary amine. And then after this, if I add one more R here and I make a quaternary salt, that is R4N positive, this is called as the quaternary salt of ammonia. So that is what we do. These all are the derivatives of ammonia derived from the ammonia by replacing one or multiple number of hydrogen atom by an alkyl or aryl group also. Okay, it can be a benzene ring also, it can be a phenyl ring also. Then we have classification of ammonia. So as I told you, there are three types of amines depending upon how many number of alkyl chains the nitrogen atom is connected with. So we have NH3 here, in which NH3, one alkyl group is attached with NH2. That's why, and see, nitrogen has a valency of 3. So it will be connected with 3 bonds covalently with one alkyl and 2 hydrogen. Then 2 alkyl, 1 hydrogen. And similarly, 3 alkyl group. So it will give you tertiary, secondary and primary amines. That is the classification of amines. Now we'll try to name them. We already have covered this part of naming in our GOC first lecture, but not a problem, we'll revise this concept. So if we talk about their IUPAC naming, they are like alkane plus amine along with their position. So amine is not taken as a principal functional group, but it's always taken as a, no, it's okay, fine. It's normally taken as a substituent only, because like being a functional group, this amine group, the numbering of the carbon atom can be done from either side. See, however, the amine group is attached over here. We will take the longest chain possible and then we will try to prioritize like this. So this is working as functional group but not as principal functional group, that we have to give it the priority on the counting as we do for this COH. Anyways, come back to the topic. We have primary amines which are named as alkane plus amines, such as ethane amine, propane 2 amine, like that. Then we have alkyl group. If there are more than one alkyl group is there, then we use N alkyl. That means, so let us say we have this question with us, that CH3 and we have a NH group here connected with C2H5. Like if I want to name this compound, what I'll do, first of all, I'll pick the longest possible chain, which is no doubt this is the longest possible chain, 1 and 2, and we have N connected with methyl here, so we'll simply write N methyl, right? N methyl, and then we have meth, so it will be like ethanamine. So this is how we write it, or ethane 1 amine also can be written. So this is how we name. IUPAC naming is done like this. Okay, in terms of normal naming, or we can say if we do the common naming, we simply use it by the alphabetical order of methyl ethyl amine or ethyl methylamine or propyl butylamine, like that, if more than one kind of alkyl group is present there. If all three are there, then we'll make it alkyl, methyl, propyl in the sort of like alphabetical order, and then we'll try to write amine. That's how we do in common, and that was the IUPAC naming. Next is your structure of amine. So how the amine is structured, and amine is trivalent. Yes, so nitrogen connected with three basically groups are here, and one of them is the lone pair. So guys, this what we can say, the hybridization if we talk about of nitrogen is sp3. We can see total state number of 4, 3 bond pair, 1 lone pair. And right, if we talk about the shape of this molecule, then it will be, what is it, pyramidal, I guess, trigonal pyramidal. This is trigonal pyramidal. And also due to the presence of unpaired electron, the angle of CNE is a bit lesser than 109.5, and guys, this angle which we are right now talking about, this is nearly 105 degree, and not exactly it is like exactly lesser than 109 degree 28 minute, which is the bond angle found in normal tetrahedral geometries. Okay, so that is what the structure is all about. Then we have the isomerism part. Isomerism, what kind of isomerism does amine show? Number one is called as functional isomerism. So guys, 1 degree, 2 degree, 3 degree, whatever the classification of amine we have done till here, these all three are categorized as the functional isomers of each other. So primary and secondary are functional isomers of each other, because there are set of some reaction which are done by 1 degree and 2 degree only, not by 3 degree, or somewhere by 1 degree only, not by 2 degree and 3 degree. We have categorized them as a different functional group, and that's why they are called as the functional isomer, which is a very amazing part. Till here we haven't categorized alcohols like this earlier. So now we have some examples here, like N-propylamine, methylphthalimine. All of three are having the same molecular formula but different degree of amines, and these three are called as the functional isomers of each other. Very easy part that has been also covered earlier in our GOC chapter itself, under the category of isomerism. Yes, we have the next part called as stereoisomerism. So guys, amine itself doesn't undergo stereoisomerism. Instead, it goes for flipping, because what happens, this nitrogen, which is a very small sized atom, and it is possessing a very big sized lone pair over it, makes it to do the flipping even on the room temperature itself, which has a plenty of amount of energy. So basically this accepts the set of light or photon or the amount of energy and gets flipped, and this flipping is very high, that it takes place like around 10 to the power 6 per minute. So this is how big number of flipping is done over here. Now let us read about this flipping part, that the tetrahedral amine with 3 different substituent and a lone pair is superimposable on its mirror image, is non-superimposable. Yes, that is why these two mirror images can be recalled as the enantiomers of each other, but we cannot resolve them into two enantiomer. Why is it so? Because they are interconverted to each other very rapidly. And why? The reason behind is the flipping, as I was talking to you about, that in this interconversion takes place by nitrogen inversion, and in nitrogen inversion lone pair moves in face of the molecule of the other. So this is how it works, guys. The transition state over here we can see from sp3 to sp2 and then sp3 it is reaching. Next is stereoisomerism. So what is the stereoisomerism? Now if you are connecting all the all tetrahedral points of nitrogen, that means all the 4 bonds are there with different like nature, or different type of 4 bonds are there, which will be having definitely a non-superimposable mirror image, and that is what we call as the enantiomer. So one of the nitrogen atom which is connected to 4 different groups, which is an sp3 hybridized nitrogen atom right now, this will definitely be showing you stereoisomerism. But yes, only when the different groups are there. If the groups are similar, let's say 2 groups are same, then it will be definitely be having a plane of symmetry, and we cannot recall this compound as optically active. Let's have a question here. Ethanamine is an example of, since when nitrogen is connected with one alkyl group only, it will be like primary. It's very simple question. This kind of question can't come in your JEE exam, promise. Methyl ethyl propyl amine forms a non-superimposable mirror image, but it doesn't show you optical activity because of the rapid flipping. And this flipping makes it existing into both of the state. You cannot isolate them. You are trying to isolating one, it converted into second. That's how it works. We have the compound CH3CNH2. Again, this might look like so many CH3 molecules are there, and it also is pretty clear that this is a 3-degree carbon atom which is connected to one nitrogen. But that's not how we measure it. We measure it like by how many number of alkyl groups it is connected to. That is 1. So this will be like 1 degree or primary. Correct answer should be A. This kind of question may come. Next question is the IUPAC naming of this particular compound. So as I told you, amines are the functional group, but what should I say? So as a functional group, you have to treat it. Do one thing. This could be a substituent. This is a substituent, and this could be your main chain, and the amine is the priority. Coming to the multiple bonds, functional group has got the priority 1, 2, and 3, and that's how we'll name it. So it will become what? N-methyl propane, no, prop-2-ene 1-amine, or we can also call it enamine. Correct answer is D. So that was some IUPAC naming of amines that we are right now studying. Next question is the compound having the molecular formula C3H9N can represent what? Like what it can represent. Surely you can find out the degree of unsaturation, and you can find if there is a double bond in this compound. So what I can do is D will be carbon plus 1, so 3 plus 1 plus nitrogen, hydrogen plus halogen minus nitrogen, so 9 by 1 by 2. This will be giving you 4 minus . So how much does the degree of this over here? 0. That means no double bond is there, no unsaturation is there. It's a simple linear chain will be there. And yeah, you can make a trimethylamine like this CH3. This can be CH3, 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 and then N. And it can also form 2 degree over here. See 1, 2, and this like this also 2 degree. This can also give you a primary amine like this 1, 2, 3. So I guess all of them can be the correct one. Okay, so how can you make isopropyl amine? Isopropyl is amine might be this like this. So I think all of this should be the correct answer. Let's see what's the correct answer given. Yeah, all okay, fine. So guys, that was some basic introductory part of this chapter, and talking about amines and IUPAC nomenclature. That's what we have already covered. Now we'll come to the first major part of this chapter, that is preparation part. And so many questions come out of these very important reactions, and one of them is, let me give you an idea, it's Hoffmann bromamide degradation reaction, very important one. So many questions have been asked previously from that particular part of this chapter. Let's have first reaction. We can reduce down aldehyde or ketone catalytically by in presence of nickel or Raney-nickel in presence of ammonia about this. So anyways, what are we gonna to do? We are first gonna to make amines which are also called as Schiff's base. So Schiff's base is made by this reaction of nucleophilic addition on carbonyl carbon. It will give you OH. Right after that, I gave you a simple idea that remove this H2O, and then the product will become what? RCH double bond NH. This is called as amine. And if you reduce amine, if you basically add hydrogen in catalytic of like catalysis of nickel hydrogen like that, it can give you the 1 degree amine. it will be giving you 1 degree amine. Okay. So guys, I was just checking about. Okay, fine. Okay, this is the reductive amination of aldehyde or ketone. So you first need to get it attacked by the ammonia, and now ammonia can also be amine. It can also be 1 degree amine, and then you can get 2 degree or tertiary or secondary like amines also using this method. Okay, so now we'll come to the next method is called as Hoffmann exhaustive alkylation. So what is alkylation? What is alkylation doing over here? So addition of the alkyl group to ammonia molecule, and do you remember, like in the very first introduction part of this amines, I told you how 1 degree, 2 degree, 3 degree are formed from ammonia by removing one H and adding the R group. Similar thing will be happening over here. We have ammonia molecule has 2 electrons over nitrogen, and a good nucleophile attacks on the R group as SN2 reaction and yields out the halogen forming. Now first it is it's like a combined product is formed over here, and this product overall is like RNH3X minus, and then HX is removed forming RNH2 over here. Okay, HX is removed forming RNH2. Then the another attack will be taking place on, this has become even stronger nucleophile now. RNH2 attacks on the R alkyl group of the haloalkane forming R2NH, relatively more nucleophilic in nature. Then goes and nitrogen attacks on the next RX, and leaving behind the HX gives you R3N. And yes, the final product will be a quaternary ammonium salt where no elimination of HX will be taking place. So that's how the exhaustive alkylation work. There is a very important part about this reaction that I want to give you is, there could be two possibilities that if we are reacting RX and NH3, and let us suppose we are taking ammonia in excess. So what will be happening? At the very first, it will be producing RNH2. And now this RNH2 doesn't have any further RX to attack upon. So this will be formed as a major product. This is your major product. And what is your major product? It is 1 degree amine. That's a very good part of this reaction I'm telling you. So let us suppose in this way I am taking Rx in the excess. So I am continuously availing the substrate to be attacked by the so formed nucleophile. So what we are doing is, now this ammonia is working as a nucleophile, and excess is Rx. Once RNH2 is formed by eliminating HX, and we have plenty of Rx here, it will be taking another attack. So what we can say that primary, secondary, tertiary and R4N positive quaternary salt will be mixture of product you will be getting. Mixture of products. Not a single product you will be getting in major. Single product can be yielded when ammonia is taken in excess. Then ammonolysis of alkyl halide, or we have some key points here. Oh sir, allow me. Hello. हाँ भैया, कहाँ पर हैं आप? So let's move forward. Sorry guys, stuck in some very urgent work. Now yes, coming back to the context, we had Hoffmann exhaustive alkylation reaction, which is a nucleophilic substitution reaction, typically SN2. If NH is ammonia in excess, then 1 degree will be the major product, as I told you, and it's not a good method as we obtain the mixture of amines here. The order of reactivity is this is SN2 reaction. So preferably this will be saying that direct proportional to the ease of leaving group or the stability of leaving group. The stability is I minus, Br minus, and then least is stable is Cl minus. The mechanism I have already told you. Let us move forward. Why are we having mechanism 2 times here? Yeah. The next reaction of preparation of amines is Gabriel phthalimide reaction, Gabriel phthalimide synthesis. So in this reaction, we already will be only getting primary aliphatic amine, not even aromatic. So let me star mark it. That's a very important part of this reaction, that Gabriel phthalimide reaction can only synthesize 1 degree amine RNH2, not even 2 degree, not even aromatic. So what happens? This okay, just directly coming here. This is a base, abstract this hydrogen, and it is forming a salt over here. This is potassium. This was phthalimide. This is potassium phthalimide. Then we have SN2 reaction where X is eliminated out, X minus, and it will becomes N-alkyl phthalimide. This N-alkyl phthalimide then reacts with a base where SN2TH reaction. You all remember SN2TH reaction? This is how the reaction takes place. This nitrogen group will depart, forming it will give you like 2 equivalent will be needed. 1 equivalent will give you R C double bond ON. This bond will be broken up and will be connected with OH group. Okay, and this will become CO because of the presence of basic group. COH will be converted into ONO salt plus RNH2. After 2 equivalent will be consumed here, it will give you this RNH2 amine as the product. Again, the very important part of this reaction that it is only providing you 1 degree amine, not 2 degree, and because this alkyl group what we are seeing is just one alkyl group that attacks over here, and once we are getting one alkyl group only on one nitrogen, it will give you 1 degree amine. This is your Gabriel phthalimide synthesis reaction. Okay, so very easy reaction, guys. You got to make the you must remember the reagent first of all, which is KOX and KOH, which is base and RX. Base and RX. Okay. Then we have Mendes reaction. We also learned this reaction previously in our hydrocarbon chapter, not hydrocarbon chapter. We read it in probably in aldehyde ketone carboxylic, that we can reduce amines using hydrogen and Rennie nickel. So guys, Rennie nickel is nothing but what I must say, it's a so nickel itself is a good catalyst. In order to increase its reactivity or its activity or its efficiency, we make an alloy using along with nickel we add some zinc and aluminium in it, and then becomes the Rennie nickel. Okay, by the name of after the name of some scientist, Rennie. So that's how we do it, and we make the nitriles. Simply add HH in both of them, CH2 NH2, like that it will become. This is your Mendes reaction. Mendes reaction happens in when sodium is taken in alcohol or LiLH4. Okay, so sodium and alcohol. Again, they will form. There will be a good reaction between them, producing the hydrogen to reduce. Next is reducing agent NaBH4. We already have learned about NaBH4, that all the aldehyde, ketone, but carboxylic acids are not. And then we also had acid halides. And one more thing you can reduce is your which is when azide also being reduced here, right? So see, once you are given with NaN3, sodium azide, N3 minus is working as a nucleophile, attacks on nitrogen, removing halogen, forms RN3, which is alkyl azide. Alkyl azide is now reduced to RNH2 using, and one ammonia molecule will be there, one RH2 has been done, and this is done by the NaBH4. It's a source of hydride ion, H minus. Then even stronger, reducing agent from not stronger reducing agent we have. Okay, maybe we have having it later on, but anyways, coming back, LiLH4 also can also do the same. Next reaction is reduction of the nitro compounds. Primary amines can be obtained by reduction of nitro compound. So passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, it can reduce down, or even using LiLH4 is working over here as a reducing agent and will give you what? Amines. Okay, so nitro compound are reduced. I remember this reaction. We used to take this reaction as Stephen's reduction. Stephen's reaction was producing nitro compound to reduce to RNH2. Next is primary amines having the same number of carbon atoms can be obtained by reduction of amide. So reduction of amide is like RCuNH2, it will become CH2NH2. But the reagent you must know, it could be LiLH4 in ether, or it could be sodium and C2H5OH. We also have covered these reactions previously in our aldehyde ketone carboxylic. Those who have not covered this chapter, please do it. I literally think that that was the most used chapter of this entire chemistry, and specifically talking about the organic. But now the remaining chapters are quite small chapters. Many of the reactions are now repeated, and that's why I am like going a bit fastly. We also have our exams very nearby, so won't take too much very long lectures. We'll just simply cover them fast and fast. You can download these notes. The link is given in the description. From there you can make either one of your short notes from there, or you can directly quickly revise this chapter like that. Next is Hoffmann degradation reaction, the very important reaction of this complete chapter, the most important reaction. I must say the most important reaction. So how this reaction works? So guys, we have amide with us. We have amide, and that should be a 1 degree amide. Amide should be 1 degree. What is the meaning of 1 degree? That connected with NH2 group, not NHR, not NR2 like that. 1 degree amide. When it is coming in the contact of bromine and NaOH, so guys, bromine and NaOH can also be written up as NaOBr. It forms a compound of like, it disproportionates, forms Br minus and NaOBr. Okay. Then next is, so we will be getting one lesser carbon atom. So let me give you one simple part of this reaction, that RC double bond O NH2, which is 1 degree amide, when it is reacted with 1 mole of bromine and 4 moles of NaOH. So that's all what it takes, and sometimes it is asked also, it's 1:4 by the way. So it will be removed with C double O. Just do one thing, simply remove this group of C double bond O and form RNH2, which is your 1 degree amine. RNH2 is your 1 degree amine, right? But how this reaction is getting, that is a bit complicated mechanism. Let's come to the mechanism part. Not so complicated, it's a very easy also, but we are not supposed to put down the mechanism meanwhile of the exam, because learning about the shortcut, how can we reach directly to the product, is more important, and it can give you the faster product if you need it. We have a base which is taking H hydrogen, acidic hydrogen from here. Why it is acidic hydrogen, sir? Because nitrogen has a lone pair here which is participating in the resonance, and this carbonyl group is making nitrogen to feel the positive charge or removal of the lone pair from here. That is why it acquire lone pair from hydrogen. Hydrogen is departed, H positive is departed. This H positive makes nitrogen with a negative charge, and this negative charge, or whatever we can say, this resonating structure, negative charge attacks of nitrogen on bromine via simply SN2 reaction, and there we get the N-bromo amide. So this is called as bromamide. What we call it as a bromamide, this is called as the N-bromamide. Then we have another base will come, make an N minus, and this will not attack on further Br2, because this is not that much good base as it was earlier, and then simply it goes, and we also do not have any acidic hydrogen to be removed, so we'll simply go and attack upon the this is the RDS of this reaction, and it is called as the alkyl transfer reaction. This is called as alkyl transfer. How alkyl is transferring? See, look at this. We are having O negative over here. The electron pair density on oxygen comes over here, and now there is two possibility because it cannot have 5 atoms, one of the bond. If we move this bond moving like this will give you the same resonating structure, not a worth. We'll simply remove our alkyl group from here, we'll add 2N, and then we'll remove the poor base, which is Br minus. Br minus is removed, and this is your alkyl isocyanate we get, and this is the most important step of this reaction. This is your alkyl isocyanate. This alkyl isocyanate, when attacked with water, it will give you what? NH2 and then COHOH, and then it will be converted into CO2 and water. So this will give you RNH2 and CO2. It's as simple as that. So those students are preparing for 2025, no need to write down the whole mechanism, just simply take this thing in your mind that the reaction intermediate somewhere we are getting is an alkyl isocyanate, and this alkyl isocyanate will be attacked by water forming RNH2 and CO2. So this reaction is also important in providing you the primary amines only, which could be aliphatic as well as aromatic. So let's say that this reaction is yielding. Okay, take this idea everyone. Let's take some examples. Let's say we are right now having C2H5, C double bond O, CNH2, which is primary amide called as method propanamide. And propanamide under reaction with Br2 and NaOH will give you what? C2H5 and simply attached with NH2 along with evolution of CO2 gas that will definitely react with NaOH and forming Na2CO3. Then we have one more example, which could be your aniline, not aniline, this is your basically your benzamide, and benzamide under the same reaction will eliminate out CO group and will make you what? C double bond O, not C double bond O, simply NH2. This is aniline. So the benefit of this reaction that you can form aliphatic as well as aromatic compounds. The products are very important everyone, even the byproducts. So this removed Na2CO3, like the removed one will be tagged and 2 Br will remove there. We are using 1 Br2 there site. So you will make 1 Br2 molecule, not Br2, they will make simply 2 NaBr because we are taking 4 that and 1 Na2CO3. So that's how we make the byproducts also. Byproducts are also important. That can be asked in the terms of stoichiometry, that how many number of this NaBr molecules are released or somewhat like this. Now we'll move forward to the next part. Next reaction is called as Curtius reaction. Curtius reaction. Okay, see one important thing I'll show you. Curtius reactions happens in this way that this is some acyl azide kind of compound we have in Curtius reaction. Exactly the similar reaction what we have just learned. Exactly like the reaction we just studied, which is Hoffmann bromamide. So what happens? This negative charge works like this, giving it a double bond. It goes for O negative, but this O negative will not lead any of the thing. This comes down, removes the alkyl group, and alkyl group again attacks on the nitrogen, forming this alkyl isocyanate. You remember the same thing is happening. Alkyl isocyanate we made there. The same reaction is happening over here in acyl azide, just simply on heating, but acyl azide should be there. This reaction is called as Curtius reaction. And if you are preparing and if you are treating it with water, then remember that two equivalents of water will be used here. HH will be provided over here. This bond will be broken, which is the I must say the most electronegative bond. And then carbon over here will be attached with 2 OH forming CO2 and water. So this will give you amine as the product. But if you are using ORH, sorry, that is an alcohol, ROH. So ROH will be giving you nitrogen will be acquired with. Okay, one equivalent of this, like make it like carbon. This is nitrogen and plus, and then attack of R OH, RO minus and H plus. Then you will see the product. This will become RNH and C double bond O, OR, which is carbamate. Carbamate, okay, some alkyl ester type of compound. And the same with RNH2. The same thing you can do is make it RNH negative, NH plus, and then attack on the same species and you will get your product. Some of the urea derivative you will get. That reaction is called as Curtius reaction. Similar reaction only. Then we have the next reaction here called as Schmidt reaction. Another very similar reaction, okay. So what is happening in this reaction is Schmidt reaction. So guys, this is your carboxylic acid. And when carboxylic acid is being reacted with the, this is called as hydrozoic acid, HN3. This leads to the formation of RC double bond O N3, which is again acyl azide. And you remember this acyl azide on treatment with, on just simply heating even, gives you RC double bond O alkyl isocyanate, RNC double bond O. And this alkyl cyanate on treatment with water gives you what? RNH2 with the removal of CO2 and water. Check out this reaction. Isn't it the same reaction? Right now we are not having initial reagent as alkyl acyl azide. Then we are preparing acyl azide from this reaction of carboxylic acid and hydrozoic acid. That's how it works. One more similar reaction, okay, I'll give the compilation of all the reactions together, but believe me, these reactions are pretty similar to each other. One another such reaction is called as Lawson reaction. Lawson rearrangement or Lawson reaction. What happens in this reaction? First of all, let me see what is this compound. Well, this compound is whatever this compound is. So this is RC double bond O NH O C double bond O R. So under basic condition, this hydrogen is departed forming N negative over here, which rearranges itself, leaving this group. See, the same thing is happening. This is again now the leaving group. Like bromine, earlier it was the leaving group in Hoffmann bromamide. N negative comes there, this goes there, alkyl shift happening, and then gives, after removal of RCO minus, we have RNCO, which is alkyl isocyanate. The same reaction is happening, alkyl isocyanate. The mechanism itself is very pretty clear to all of you, and it's very neat and clean, won't disturb too much. Right after attack of water, you all know the mechanism. H positive available will be nitrogen, and then carbon will be taking OH and forming what? RNH2, 1 degree amine. Next step is very simple to all of them, and CO2 will be eliminated out. So just look at this very important part of this reaction. Look at this, which is giving you all of these reactions all together. I am getting aside. Please note down all of these reactions, which are very similar reactions to each other. Very much similar reactions to each other. I hope this is pretty much clear to all of you. Now, let me take you to some questions. The major product of the reaction when methyl bromamide is treated with excess of ammonia. So, what is this by the way? Methyl bromide is CH3Br, and it is treated with ammonia which is taken in excess. So, I told you once that if only one substrate is there to attack upon, it will give you 1 degree amine as a primary product or the major product. So CH3, NH2 is the major product, and by the removal of NH2, sorry, HBr. So methanamine is the, I think, correct answer. Next is, there's a reaction. There's a reaction in like it's a reduction reaction of cyanide to amines, and this reaction is called as Mendes reaction. It's a very simple reaction, just a naming reaction. No need to take so many things in mind, just be simple, be straightforward. Reduction of aromatic nitro compound with this FeNHCl, good reducing agent, will produce hydrogen gas. That reduces nitro compound will be converting into aniline. Very simple, like hydrogen will be converted into NH2 and water is formed. So what is the correct answer? Aromatic primary amine, aniline. Acetamide is treated with following reagents separately. Which one of them will yield methylamine? So what is the acetamide? This group is called as acid, and along with NH2 will become amide. Then reaction with Br2 and NaOH will yield what? Methylamine. So CH3 NH2 along with the evolution of CO2 gas that combines with nitrogen. So the sodium forming Na2CO3 and 2NaBr. So the correct answer should be NaOH Br. It can also be written as NaOBr because sodium hydroxide with bromine forms NaOBr. The Hoffmann bromamide degradation reaction, the number of moles of NaOH, and read this, I told you this is 4:1. So where is the 4:1? C. Gabriel phthalimide synthesis is preparation of primary aromatic, no. Secondary, no. Aliphatic, whatever, yes. Tertiary, no. C. Correct. Alkyl halide RX on treatment with KCN followed by reduction. So guys, first of all we have RX, K positive, CN negative, attacks SN2, gives you RCN, and then upon what reduction, then it will give you what? RCH2NH2. So this is 1 extra 1 degree amine is there with 1 extra carbon atom. B is the correct answer. Now try this question, everyone. Try this question. That alkanamide which on Hoffmann reaction gives you 1 phenyl NL. So first of all, I'll make this 1 phenyl ethylamine. Ethylamine. What is it? Yeah. CH2, CH3. This is 1 phenyl ethylamine. So this is CH3 here, and this is CH. This is NH2. So from where we are making it, just introduce one C double bond O. Remember C double bond O group over here, then it will become what? Like this. So this is an amide now. Also, how are we gonna name it? 1, 2, 3. Arey yaar, how many carbon atom did I make here? Right. So what is the name of this amide, everyone? Two phenyl ethane, not ethane, method propanamide. Two phenyl propanamide. I think A is correct. A is correct. So A was the correct answer, and so it's an easy chapter. Majority of the reactions are the one which we have already covered in previously in other chapters of organic chemistry. We have physical properties of amines now. So we are going to deal with the physical properties of amines. So amines are polar in nature. Amines are actually lower aliphatic amines are gases with fishy odor. They smell like fishes, and I haven't smelled a fish any, so I can't say how this fish comes up. But you better visit some fish market someday and then observe how amines, lower amines like primary amines, methenamine, ethenamine smell like. And primary amines with more than 3 carbon atom are liquid, and higher one are the solid. The lower aliphatic amines are soluble in water also because they can form hydrogen bonding with water. But as the solubility will decreases as the molar mass increases, because the hydrophobic part which doesn't get dissolved in water will be measured there. Similar things we have already studied, so I'm going a bit faster. We are having examination very soon, so won't waste too much of your time. We have the next session. Do attend my next session, that will be on biomolecule, and I have seen this that as the reduction of this syllabus has done previously from 2024 JEE Main exam. So from then only biomolecule has its own importance, and it has been asked so many times. So I would expect you people to please study biomolecules. At least it will give you one question at least for positive 4 marks. We have amines are soluble in organic solvents like alcohol, ether and benzene. The order of boiling point is 1 degree, 2 degree, 3 degree. Okay, earlier I was thinking that it should be 3 degree, 2 degree, 1 degree, but not like that. Why is it so? Because this nitrogen, as many as number of hydrogen are there, so they are pretty much able to form the H bonding with higher extent, and they will close, and they will be staying close with more number of molecules. So 3 degree will be having least extent of H bonding. So I can also say this is the order of boiling point, which is directly proportional to the extent of H bonding they are showing, extent of hydrogen bonding. Next is that 1 degree and 2 degree amines are engaged in intermolecular association due to hydrogen bonding between nitrogen and one of the hydrogen two. Okay, we have seen this here. Please don't waste our time. So we have RNH2 here. H will be connected here also, here also. So you can see more number of H bondings are taking place here. Only one bonding is there. There is no intermolecular H bonding in tertiary because there is no hydrogen as such to make the H bonding. Higher amines are less soluble in water, and lower aliphatic amines. Why is it so? Because of H bonding is higher in amines, or large alkyl groups are higher amines. So more H bonding in higher amines, wrong, and large alkyl groups in higher amines restricted not to get dissolved easily because that's a hydrophobic part, repels water, doesn't get dissolved easily. And arrangement of the following in increases of their boiling point. Boiling point is directly proportional to 3 degree, 2 degree, 1 degree. 1 degree is the highest one. So can you see the correct order here? Okay, along with it we also have alcohol. So alcohol will lying at the highest peak. Alcohols are the toppers. So I can see that you people are now participating, and that's a good. Darsh Tarware has given us. Sorry, Tawar has submitted me the answer here. Sorry. Where were we, by the way? Yeah. So we have alcohols are the toppers only, and then we have 1 degree, 2 degree, and 3 degree. So this will be the correct answer. A is the correct Tawar. Keep it up, dude. So till now we have seen that this chapter is not too difficult. It's very easy. There are few set of chemical reactions that we have to take a very specific attention of. The very one of them is Hoffmann degradation reaction. The another one is Gabriel phthalimide synthesis. The very next is alkylation, exhaustive alkylation, where you can get the majority product as primary amine and where can you get it as a quaternary salt. Now, apart from this all, now come to the next part of this chapter. Let's jump to the chemical reactions of amines. So amines have lone pair over there. They can easily show you SN2 reaction, nucleophilic, substitution reaction as a attacking reagent, as a living, as a what should I say, nucleophile they can attack, and also they have the basic character because of the availability of the lone pair of the nitrogen. So amines are basic like ammonia, and the basic nature of ammonia is due to the lone pair of the nitrogen atom. But if you see the same thing in case of aniline, it gets engaged in the resonance also. So the availability of lone pair of nitrogen is lesser to be attacked by H positive. That's why aniline is weaker base than the normal amines. Basic strength is stronger bases than ammonia, and basic strength should be what? 3 degree, 2 degree, 1 degree, and this happens in what? In gas phase. This is the order of Kb. Kb as in like dissociation constant of weak base. The basic strength is directly proportional to Kb, and Kb increases as the degree increases itself. But the extent of H bonding in water restricts tertiary to become the, like, it cannot be easily solvated. So most stable cation will be of primary one, because it will be giving you RNH 3 positive, 3 hydrogen to make the H bonding with water, and that makes it more stable than other 3, and that is why the correct order should be 1 degree, 2 degree, 3 degree, and then even ammonia should get the highest. But if we talk about all of them together, all the factors right now, let it be a factor of inductive effect, we have resonance effect, we have extent of hydration, every electronic as well as the hydration effect we take together, the correct answer comes up like this. In case of methyl, we have to learn the order of, now where is it? So basic strength in aqueous phase depends on 3 things: induction, solvation, and steric, and mentioning all of them 3 together, as you can see the extent of H bonding. And you also see that solvation is getting very difficult over here because of bulky groups are attached here which are hydrophobic in nature. So we have the order over here that we have to learn down. These 2 cheat codes we have to remember: 2130, that for methylamines, and we have 2310 for ethylamine and others, and general amines can also be categorized like this order. So whenever any random example is given and we are going to find out the basicity or basic strength over there, just simply follow the order of 2310. 2 degree will be having the highest, 3 degree, 1 degree, and then 0 degree. You might be wondering, like, how come we from 1 degree directly extent of hydration was more, and from 3 degree inductive effect was more, increasing the electron density of nitrogen and making it more basic. How come we reach to 2nd degree eventually? But yes guys, that's the truth, that it has been determined practically, and we are explaining all the concepts behind it. But we also got to know that 2 important major points, which are hydration energy or solvation, and the another one is the inductive effect, electronic effect. These 2 are contradicting with each other, and that gives you 2nd degree as the most basic. Even if any kind of question, let's say if I'm giving you one question and the question simply says like this: like this, no, so let's say if I'm randomly assigning them number as A, and this is B, and this is C. So what has been asked, that we have to find out the basic strength order. That's a general question is given to us, and we have to find out the basic order. Tell me guys, what should be the correct answer? The basic strength will be the most it for, this is what, 2nd degree, this is what, 3 degree, and this is what, 1 degree. 2310, as I told you, the correct answer should be what? 2 degree is B, 3 degree is C, and then BC is the correct answer. Order of basic strength Kb. So that is what I'm telling you guys. Okay, take this order in your mind every time, and it's very helpful, by the way. So now we'll move forward. Basic character of amines. Okay. We have basic character. If you guys want to study this acidic and basic behavior of all organic compound, and in just one single lecture, everything in very detail, please visit my lecture of GOC, and probably the 2nd and 3rd lecture of GOC, where I have explained the applications of electronic effects. There I have explained the stability of reaction intermediates as well as the acidic and basic effect as one of the application of electronic effect. Please visit that lecture, please watch that lecture, because it has plenty of things to explain about, and even this theory is also explained over there. This is the basic strength. So first of all, that ammonia is more basic than aniline, because aniline has these much number of resonating structure where electron density is distributed over the whole molecule, and that makes it less availability over nitrogen to be attacked by hydrogen, because this is a stable molecule. It's a relatively stable molecule because it has its electron density distributed all over the molecule, and that's why it's stable. It doesn't want to get attacked by the H plus, or it wants to get attacked on the electron deficiency side. Anyways, now what makes an aniline more basic is the electron donating group. That increases the electron density, by the way. It's a plus M group, and this is a minus M group, and minus M group withdraws the electron density and makes even lesser electron density available over here. So guys, that's how we measure it. So let me just give you another idea here, and we study this thing as a SIP, or we call it ortho effect. Ortho effect in aniline. What is ortho effect in aniline? We also call it this effect as SIP effect, steric inhibition in protonation. How does this work? Let's see. So guys, whenever we have a simple aniline and this aniline is attached with an electron withdrawing group, then it will definitely be having lesser basic than normal aniline, because electron withdrawing is decreasing the electron density present on nitrogen atom, making it less basic. And yes, and this could be ortho, meta, para, wherever you want to attach it. Similarly guys, if we have aniline with us and there is a electron releasing group, but the releasing group is at meta and para only, not on ortho, then it will become more basic than the normal one. Why is it so? Because it will present at meta and parallel, whatever the position, but it will increase the electron density, by the way. It's an electron releasing group. Okay, this is aniline, this is aniline. These all are the order of Kb I'm talking about, their basic strength I'm talking about. But what will happen if we switch it to the ortho? So whatever the nature of group, if we are applying a group on our ortho position, now this could be electron withdrawing group or electron releasing group, its basic strength will always be lesser than a normal aniline, normal aromatic aliphatic, normal aromatic 1 degree amine. This is the order of basic strength Kb. Now why is it so? And this is what we call it as the ortho effect. So how this steric inhibition in protonation occurs, I'll explain it to you. So what usually happens whenever we have aniline and aniline attacks on any acid and it's H positive, it forms anilinium ion. It forms anilinium ion. Which you can see is easily hydrated by water molecules like this. But now what we are doing is we are providing it with another group, G group, present at the ortho position. Now irrespective of the nature, whether it's an electron releasing group or it's an electron withdrawing group, it directly affects the whole group. How? Let's see. So after accepting H positive, this is basically difficult to solvate or hydrate due to steric hindrance of group G. Now G doesn't make this anilinium ion, this ortho substituted anilinium ion to to hydrate it easily, and that's why it's not stable in going in forward direction. And so let me just give one example over here, and depending upon the nature of the group we are attaching with the aniline. So let us say this is your example of aniline. We are connecting aniline with nothing, then connected over here aniline with ortho position of CH3 group. Now CH3 is an electron releasing group because it has a positive H effect, hyperconjugation, but only at ortho and para position. Ortho and para with respect to the given group. Let's say this is first, this is second, this is third, and this is fourth, and we have to give the answer that what is the order of basic strength. So see what is happening here. Nothing. There's no external group which is providing you any external electronic effect. This is at ortho position. It provides you positive H effect more than positive I, but more than that, SiP will work steric inhibition in protonation. Once it accepts the H positive from the acid, it will give you a positive I effect only, and this gives you positive H more than positive I. So this, because it is giving you positive H effect and providing more electron density of nitrogen, fourth has become the most acidic in the nature. Then we have second could have been there, but because of SiP it will go at the last. Then we have third, first, and the worst will be the second because of the SiP. This is the order of Kb, and this is why at the last due to SiP. So that's how it works. Fine guys, moving forward, we have some questions to be solved on basic strength, and then we'll come to the another chemical properties as well. We have indicate the correct statement. This is acidic, it's written down, it's acidic. Let me see, this is your C2H5. It's not less basic, this is 2 degree. So okay, this is the neutral compound, it's a salt by the way, okay. And now coming to this part, C could be the correct answer. Let me check it if it is. So you remember 2310, 2130. So we observed that 0 degree or ammonia is always a lesser basic acid than all 1 degree, 2 degree and 3 degree. Then we have which among the following has the least solubility in water? The least solubility will be of 3 degree undoubtedly. And I think not just 3 degree. It should be, because this benzene ring, it's hydrophobic in nature, everyone, and it's a bulky thing. Oh, this is your hydrophobic part. The basic character of methylamine in vapor phase. Vapor phase bole to gas phase. No hydration, no tension of solvation. Just simply take this thing, 3 degree, 2 degree, 1 degree and 0 degree, which is ammonia A. Which of the following is least basic? Whenever no medium is mentioned, if no medium is mentioned, always assume aqueous. We have to assume the medium as aqueous medium. This question came in JEE Main 2021, and this question says that which of them is most, so least basic. So guys, you know what, we have to find out that thing where we can see that it's like the electron density is shared somewhere. So can you see the first example? And if you observe the first example, we see this type of arrangement is here. And you know what, this keeps on doing the resonance, and there are like two sides which can ask it to do the resonance, making this electron density distributed in the molecule and not concentrated to be attacked by the proton. Next is reaction with aldehyde. You already know this reaction. We know Schiff's base or amines are formed as the product. Yeah. So no, not amine, these are aldimine. Aldimine or amine means aldimine or ketimine, whatever it is. So just observe these reactions. So that's the reaction we already have studied in the aldehyde and ketone called as Schiff's base. I'll move forward to the next equation, next reaction, which is alkylation, and we call it as the Hoffmann alkylation itself. So that's what it works. Amine, 1 degree amine will react on the Rx, and SN2 reaction will be happening. RRNH secondary, then tertiary, then quaternary salt will be formed. Next we have acylation. Now the meaning of acylation is attacking upon C double bond of R group. So attacking on the carbonyl carbon, it can lead to the formation of amides here. How? Let's see. This is some N-ethyl ethanamine. So it's a tertiary, so it's a secondary amine, and it's attacking on this carbonyl carbon. Cl minus is a very good leaving group and a weak base. It leaves out and forms a compound like C double bond O and this compound. So this is amide actually. So acylation means attack of ammonia, or sorry, not just ammonia. Okay, ammonia could be there. Like ammonia can produce you 1 degree amide, and amine RNH2 can give you 2 degree amide, like N substituted amide. We have another important reaction called as COP elimination. I hope you all remember this reaction is a part of EI reaction. When I was teaching a reaction, like as a chapter, it was a chapter I was teaching you under GOC itself. Reaction of mechanism was the name of that session. And then I explained that what happens in COP elimination. In COP elimination, we use an N-substituted hydroxylamine and which upon heating, so let's say this is OH, let's let it be O minus and N positive. So hydroxylamine, it's like amine oxide, tertiary amine oxides with beta hydrogen. So I'm also just quickly doing the recap, like what was the reaction about. So guys, this is alpha and this is your beta. So whoever has the beta hydrogen will depart from here like this. Depart like this, and this group depart like this. So one hydroxylamine as the product is formed, another is the alkene. Alkene is formed as well, but always think that if it gives you Hoffmann alkene, Hoffmann alkene is the major. Like if there is a possibility of even more substituted alkene that can be formed using this given R groups connected with nitrogen in tertiary amine, okay, now we'll move to the next question from here, next reaction. Okay, we have some questions. So when aniline is heated with benzaldehyde, then the product will be what? So aniline is what? A primary alkene, primary amine, and working as a nucleophile and attacking on what? Benzaldehyde. So the rate of reaction will be very small, very slow, because both of them are the bulky groups attached, and one of them is decreasing the electron density of nitrogen, another one is basically providing the steric effect also. So this is how this will be looking like. NH, then we have C double bond O, and another benzene like this. So N-phenyl benzamide. This is called as N-phenyl benzamide. Arey yaar, no yaar, what have we formed here? Like that. This is correct. The reaction happens in this way only, but one carbon atom cannot have two things. One of them is OH group there, another one is NH group connected over here. It removes out H2O from here and gives an alkene as the product. Not alkene, a double bond with nitrogen and carbon called as imine, and imine are called as Schiff's base. So Schiff's base is the correct answer. Moving to the next question, the reaction of primary amine with aldehyde gives you what? So primary amine with aldehyde will give you what? This is RNH2 and it is attacked by aldehyde. So this is R dash. So remove water molecule. It will become what? Rn double bond C R and this is H. What is it, by the way? So it's aldimine only. The compound which gives you ethane as a product in COP elimination. So you got to find out where can you get ethane. First of all, it should be tri-substituted. So let us say if it is trimethylamine, it will give you no reaction such as because no beta hydrogen. But yes, triethylamine could be the good answer. Like this is having these all are similar only. Similar groups are connected, so there is no hesitation in removing what group has to be removed like that. This is gone like ET, and this is also ET. One more ET, and if we are heating it, so first oxidizing it to form the this ammonium oxide, and then on heating it, it will give you what? CH2 double CH2. So the correct answer should be what? Along with this will be ET2 NOH. This is hydroxylamine. Correct answer should be D. Okay, what you are saying, man? Where? Sir, B, but I'm not understanding. Which question we talking about, by the way? Where did we get B as the answer? B aldimine. Oh, this is just named as aldimine. So this is imine. This is called as 2 degree. This is like imine, and this imine connected with aldehyde become aldimine. Next question. The major product of the reaction where this reaction, this compound is attacking by the ethyl formate and one equivalent. This question came in 2019, everybody. This question appeared in 2019. So we have a reaction with ethyl formate here. So as an ester, it is reacting. I'm not getting better. Please clarify what question are we talking about. So ethyl formate is OET. So let's say we attack because see nitrogen has more affinity towards carbon to form the bond than oxygen, and if the carbon will have negative charge, that would be with even higher extent of attacking here. So this reaction will be a in the first reaction it will be like SN2TH reaction, and this will be eliminated out. The product formed will be in terms of OET. Okay, so we have CH3 CHOH CH2 CH2, we have NH here, and NH now is connected to C double bond OH. So this is how it look like. Now where can you find this question, get this answer? I guess option B is matching, right? Only option B. Let me see. B is correct, guys. Okay. There was SN2TH reaction kind of question, and where the nucleophile was an amine. Okay, an amine was the nucleophile. Now we have one reaction called as Carbylamine reaction, and Carbylamine reaction is a test of identification of primary amines. So aliphatic and aromatic, both primary amines on heating with chloroform and enolic potassium hydroxide means alcoholic KOH. It gives you isocyanide or NC, which are foul smelling substances, and that is a test of identification of primary amines. But secondary and tertiary degree amines do not give this test. This reaction is used for the test of primary amine. The reaction is simple, and then we'll come to its mechanism. This is your RNH2, and it is being attacked by the chloroform in with respect to this, which forms a CCl2 dichlorocarbene, and RNC is the product form, which is foul smelling substance, and that is a test of identification of primary amine. That there we have the mechanism. So we all know that initially with NaOH or KOH or with the chloroform, you get a reaction intermediate called as carbene. So this carbene is actually an electrophile. It's always electron deficient. So nitrogen attacks over there on carbon, acquiring a positive charge, and carbon acquires a negative charge, where chloride ion is removed by the attack of OH. A simple reaction occurs, forming what? RNHCCl. Next attack of water will take place, Cl will be removed out, and it forms RNC as a isocyanide. Isocyanides are bad and foul smelling substances, identification of primary amine. Let's have one question over here. A compound A is converted to B by the reaction of a CaCl3 and KOH. If compound B is toxic and it can be decomposed by C, A, B, C can be what? It can be decomposed also, very nice. So we will come and find out. So first should be what? Primary, secondary amine do not give this reaction. So secondary amines will be cancelled out. Only these two are going to give. The so formed product will be a nitrile compound. No, it will be an isonitrile only. So C is the correct answer. And yes, in the presence of concentrated HCl is there. In the presence of concentrated HCl is there. Then this NC, carbylamine, will react and form a compound. Next we have a compound X on treatment with Br2 NaOH gives you C3H9N. So which of the given positive carbylamine test, okay, which gives a positive carbylamine test? What is this, by the way? So carbylamine test was given by 1 degree amine, I remember. So where can you find 1 degree amine or similar kind of thing? I guess it's here. So this is your CH3, CH2, C double bond O, CH2 and then NH2. So what you need is just 1 degree amine. Next is introduction to aniline. So till now we have studied about the 1 degree, 2 degree, 3 degree amines only, and amines, their preparation, their properties, their chemical reaction. Now we'll come to aniline and how it is created, how it is made, and this is how it look like, and one of the very starting material used for the sulfur drugs in aniline. And aniline is a primary aromatic amine which consists one NH2 group that we all know with a benzene ring. So what reaction does it make? We will find out, and it's orthoproducting. Okay, so we all know that aniline, this is how aniline look like, and one of the resonating structure of aniline is this. So we can start it from there. We know that this benzene ring gets electron density from nitrogen of the lone pair present at the nitrogen and making it electron rich, and this negative charge appears at the ortho and para positions. Ortho and para positions with respect to ammonia group, this amine group, NH2 group. And yes, that's why we say that reaction is ortho para directing in nature. So this is how it make the resonating structures. A negative charge appears only on ortho and para positions. That's why we say that electron releasing group, or like a positive M or positive R groups are like mesomeric and resonance group are ortho para directing in nature toward electrophilic aromatic substitution. So if one electrophile want to attack on this basically reaction, this substrate, it will attack only on the ortho and para because this is electron rich. And the same thing we can do over here. We can, and at last this negative charge comes here, and the negative, this positive charge of nitrogen is removed, forming the first and last is the same with alternate positions of the pi bonds. So this is how it look like. So ortho para directing in nature, NH2 group is activating because it increases the electron density, and since nitrogen and carbon can form easily 2p2p bonding, which is very good kind of bonding, so that's why this is very strongly electron activating group. This is strongly activating in nature. We have next reaction called as nitrobenzene. So right now we are discussing about the electrophilic aromatic substitution that we already come across in so many chapters till now, but we'll take an idea that one of the hydrogen will be eliminated out from ortho and para position and will be substituted by the electrophile. So how the electrophile formed over here? So this is, let's say FeCl2 is there. What we are doing is, okay, we are simply SnHCl we are using, or like iron and HCl, that will give you hydrogen to attack upon as a reduction. So from chlorobenzene, if I want to, okay, I'm trying to make NH2, sorry, I've reached somewhere else, must say, we are right now trying to form NH2, which is aniline. So we can react it with ammonia, with CuCl at high pressure, it will give you, okay, aniline. We are trying to prepare aniline. From chlorobenzene also we have, isn't it something that we already have come across? We have done it earlier, have we? No, that is different reaction. I remember I was with the diazonium salt we had, and then we had plenty of reactions from there. Gabriel reaction, but okay, well, that is different. That is different. That is actually a reversal of the reaction. From diazonium salt, we are preparing the halo arenes. Anyways, this reaction, let it go and learn all the reagents. We have from phenol, we have zinc chloride and ammonia in presence of high pressure. It can give you high temperature, high pressure gives aniline. These are some reactions of preparation. We also have Hoffmann bromamide reaction. We right now have studied about it. One CO group will be eliminated out, NH2 will be directly attached here. Mechanism is already all gone through. Which of the following reducing agent is most suitable for the reduction of nitrobenzene to aniline? So anything is fine. You can pick. What's the meaning of most suitable to aniline? So I think it should be iron HCl. So iron HCl is most favored for this reaction, most suitable. The other one can form any other product like that, and that's why we avoid in order to make it reacted with other reagents. LiLH4 could be the stronger, can even reduce the benzene itself, so that's why not using. So it's a selective product which we are getting using iron and HCl. Question is, identify the bean presence of the sequence of the reaction. We have benzene reacting with concentrated HNO3 H2SO4. So it's nitration happening over there, and then nitration on reaction with metal and acid. We just have come across with it. NO2 group will be there, and it will give you what? Simply aniline. Correct answer should be B. Identify B. So it's done. So then we have chemical reactions of aniline. Now we have what? Chemical reactions of aniline. So we know first thing very all. The first of everything is known to us. The reaction that we are going to use is electrophilic aromatic substitution, because it's a electron rich group is attached over there, bringing negative charge toward the electron this benzene ring, making electrophile more to be attacked upon. So if we do the bromination, and the bromination is carried out in water, a more polar medium, where we know that aniline is strongly activating group, all three sites where negative charge was induced or negative charge was seen in the resulting structure will be attacked by bromine positive. So bromination, how do you prepare the monosubstituted? You already have got a tri-substituted product, and if you want to attend monosubstituted, then you need to do the acylation. Why? We are supposed to decrease the activity of NH2 group by adding this acyl group. This is called as the acylation. How you do the acylation? It's simple, that if we get it reacted by, not given, if we make aniline first to be attack upon acyl chloride, which is CH3 C double bond or Cl, it forms first, then after removal of HCl, that's why we should take a pyridine as a mild base which can neutralize this HCl, and the reaction goes in forward direction like this. So this something is a relatively lesser activating group, and yes, now using this you can respectively get your products in ortho and para positions. So see, now if you attack, you will be getting ortho and para, but because of the para has the lesser steric hindrance, it will be giving you as a major product. Ortho will be there in lesser. Then by treating it with acid or base, you can directly reach to NH2. Similarly, if the reaction is carried out in non-polar or weakly polar medium apart from water, like CCl4, CaCl3 or CS2, the reaction also gives you mono-substituted products. Right? Next is nitration. Addition of nitro group. Again, nitration happens at different positions, but the order of yield is very different. Okay, so let's see. So nitration, we all know, concentrated H2SO4, concentrated HNO3, we use it, and that gives us NO2 positive. NO2 positive as an electrophile, which is called as nitronium ion, and this NO2 positive attacks on ortho and para positions, but this reaction is carried out in acidic medium, and this acid attacks upon the NH2 group of aniline, forming an anilinium ion, which is now meta substituting in nature, meta dominant in nature, meta directing in nature. So it will give you ortho is only 2%, 4751. This is important. This data is itself important. So now what we have to do in order to recover it, and if you want to get the ortho product in measure, then you need to do what? Nothing, just wait there. Carry out the reactions in basic medium then. No, first you do it. I guess you should do the acylation itself. See, acylation we are doing. After acylation, it has become what? Now it is something, it doesn't have an acidic hydrogen. Sorry, not acidic hydrogen. We want to be affected by the acid. Keep on doing its work. When para will be there as the major product, para and ortho will be there as the major product. Next comes the sulfonation. So aniline react with sulfuric acid or fuming H2SO4 or SO3, produce NH3HSO4, which is anilinium hydrogen sulfate, which further attacks upon ortho and para positions respectively, forming this kind of ion. Now see, this is an acid and this is a base, weak acid, weak base. This will release H positive, this will acquire H positive, acquire positive charge, negative charge. Such kind of ion containing both positive and negative ion is called as Zwitter ion. An ion which is containing both positive and negative ion is called as a Zwitter ion. Friedel-Crafts reaction. So guys, we must know that aniline doesn't give you Friedel-Crafts alkylation and acylation both, because this Friedel-Crafts reaction takes place in the what was the reagent we were using? And Lewis acid, AlCl3, I guess. AlCl3, and AlCl3 being Lewis acid being attacked by this, forms an adduct which is a salt, and thus no reaction takes place from further. There is no nitrogen available for the attack, and it is also now deactivated. So that's why it doesn't happen, neither alkylation nor acylation works. Then we have oxidation of aniline. Oxidation happens what? Aromatic amines are oxidized to various products depending upon the conditions, such as under strong oxidizing agent like Na2Cr2O7, K2Cr2O7 or concentrated H2SO4 like that. This can be oxidized to para-benzoquinone, which is brown in color, para-benzoquinone. It's a simple reaction, just directly learn it, that's it. Similarly, that is why I was talking you about that why didn't we pick nickel and hydrogen by that time? Why we are picking iron and H2O? Because it's a selective product which we are receiving as aniline from nitro product. But if you do the same thing in presence of NiH2, even your benzene ring will be what I can say, reduced to simple cyclohexane. Let's have some questions. Aniline on heating with concentrated H2SO4 at 460 Kelvin gives you what? Aniline on heating with concentrated H2SO4 gives you what? Benzo sulfanilic acid, I guess. Now activation of benzene and NH2 and aniline can be reduced by acylation. So acetyl chloride is good. Which of the following compound will form significant amount of meta product? See, this is a JEE Main 2017 question. So I'll give you simply meta at mononitration. So meta, only this can give you the meta, because all of them are highly electron rich. Will give you what? No, sorry, what did I do here? Which of the following compound will form significant amount of meta product on mononitration reaction? Okay. Anyways, this will give you all three. This will give you which of the following compound will form significant amount of meta product on mononitration? So C cannot be correct, guys. C cannot be correct, because C will make what? Ortho and para. In fact, all. Let me check. Which question was this? JEE 2017. पास आए दूरियां फिर भी कम ना हुई एक अधूरी. So my bad everyone. I personally think that we are working on the same concept and this should be the correct answer. That gave us like 52% para, 47% meta and only 2% ortho. So this is the correct answer. Note this. Now we have diazonium salt and now we'll take a breakfast break from here. We all need to eat something. Keep yourself fit, keep yourself hydrated, keep on drinking water as much as possible. So we'll connect by 15 right after 15 minutes and then we'll start solving our diazonium salt thing and then some tests for the amines we'll do in next 15 minutes. Until then, take care everybody. Don't go anywhere. Just stay over here. So guys, we had an amazing energy break, and now we are back. So we'll resume our amines chapter, out of which we have covered till here, till aniline we have covered. Okay, so now diazonium salt is one of the things which is left right now. So there is a very easy method of preparation of diazonium salt. First of all, let us know what is diazo. So nitrogen N2 group, which is connected with one of the alkyl, or anything could be the another group, as in halide or cosulfate, let it be. Okay, so these kind of things are called as diazonium salt. So this is one of them is alkyl or aryl. Then we have N2 group with X negative. X could be uni negative ion. Anion. Okay, so name of the parent hydrocarbon, then we had diazonium, and then become the name of the anion. This is like this, the name of this will be benzene. Okay, this is benzene diazonium chloride, then this is benzene diazonium bisulfate or hydrogen sulfate, same. So we have two type of diazonium salt. If the alkyl group is attached over there, it will become alkyl diazonium chloride, which are highly unstable even at low temperature. But aranium diazonium salts are stable at low temperature, around 0 to 5 degrees Celsius. We also have some resonating structures of diazonium salt that provides us that N2 group over here is a electron withdrawing group. This is an electron withdrawing group. Okay, provides ortho and para positions with relative ortho and para position acquiring the positive charge. Then how is it prepared? It's prepared by, it's a very simple reaction, everyone, that we have to remember. It's a very easy reaction that we will freshly produce the nitrous acid, because nitrous acid on standing gets converted into nitric acid as well as nitric oxide, undergoing disproportionation reaction. So simply we will prepare H2SO4 plus NaNO2. It gives us Na2SO4 plus nitrous acid HNO2, which is the freshly prepared nitrous acid. The freshly prepared nitrous acid will be further reacted with aniline under 0 to 5 degrees Celsius. The reaction occurs and forms diazonium chloride like this. Okay, got it, everyone? This is your benzene diazonium chloride salt. So anything else apart from it? So you cannot store this salt, and it is immediately prepared in the reaction and immediately used in order to create a required product. Then we have these are some set of reactions which are very important reactions, everyone. Please look at these reactions. We already have studied these reactions earlier while preparing the aryl halides. You remember that aryl halide, like chlorobenzene, bromobenzene, cyanobenzene, and this Cu2Cl2 and HCl. This reaction is called as Sandmeyer reaction. These reactions are called as Sandmeyer reaction. And these reactions in copper powder and HCl, these reactions are called as Gattermann reaction. Then fluorobenzene, where is fluorobenzene? Now this reaction is called as Boltzmann reaction, and the respective reactions are here. Okay, like that. Now coming to the diazonium salt reactions, we are going to study about one of the reactions where we retain the N2 group over there. Another reaction will be there where N2 group will be eliminated out. Where to retain it, one of the reaction is called as coupling reaction. So in coupling reaction, one diazonium chloride is, we all know that diazonium salt is actually working as an electrophile here, isn't it? Yes, it is. So this is the phenol, and this is happening electrophilic aromatic substitution reaction. This group attacks over there. Attacking here, removing the hydrogen, becomes N double bond N, and this is your phenol group. This has become para hydroxy azo. This is azo group, azobenzene, para hydroxy azobenzene. This is orange colored dye, and we have to carry out this reaction in basic medium so that the reactivity of phenol increases and para substituted product is obtained. Okay. So anyways, let it work. So this is called as a coupling reaction in which diazo group will be retained, not eliminating out of the molecule. We have another such reaction in which, okay, this is a electrophilic aromatic substitution reaction. No need to just you can just have an idea and can find out what is happening here. So mechanism is being explained here. Phenol in alkali make it O minus, very active for attacking by the para position. Then it forms the N double bond N group, diazo. Then it is with aniline. So aniline, we already know that aniline is also orthopara directing in nature towards electrophilic aromatic substitution. Now this is an electrophile here. Electrophile goes and attack on the para position where hydrogen is eliminated out, and the product will be this, which is called as para-amino azobenzene. Para-amino azobenzene is another orange colored dye, not red. This is yellow orange dye, and the same reaction also happens in basic medium. Reaction involving the retention of diazo group. What are those reactions which involves what? The reaction of diazo group. Okay, this is the already we have explained, no? Let's see one question, everyone. Let's see one question. Compound A and B are respectively what? Aniline with NaNO2 and HCl will give you HNO2 acid, and that converts it into N2 positive and Cl negative. Which HBF4 it will give you what? N2 plus HBF4 minus, right? Negative of then it releases N2 HF BF3, and there becomes the fluorobenzene. There becomes the fluorobenzene. So benzonitrile and fluorobenzene. When NaNO2 and dilute HCl were added to amine at 0 degrees Celsius, an ionic compound is formed with and a colorless gas was evolved. The amine is what? At 0 degrees Celsius, that means it's not stable. That means it could be any amine, but it should not be aromatic. It should not be aromatic. A primary aliphatic amine. Okay, aryl amine we cannot use there, right? Only to 1 degree amine can undergo this reaction, and 1 degree aliphatic amine, if it is there, so R N2 plus Cl minus is highly unstable. Gives you R positive, N2 plus Cl negative. The increasing order of diazotization. The increasing order of diazotization. So, diazotization reaction is actually an attack of nitrogen to the nitrosyl group. Nitrogen to the nitrosyl group. So, higher is the negative charge there, higher is the rate of reaction. So, what do you find? An electron donating group will help. So, see, what I'm trying to explain is this group. First of all, let's say the A will be actually A is aliphatic, so it will be having the least one. This is aliphatic. B is simply with this, but what I can see is this is a minus I group, and this is somewhere plus M group is there on the ortho position. So it's proportional to the negative I effect. Let me see, electron withdrawing is stabilizing this or what? So NO it's being attacked by NO. So guys, this is all dependent upon the stability of aryl diazonium salt is due to the resonance. An electron donating substituent increase the electron density on benzene ring, and they increase the stability of diazonium salt. So electron releasing group are stabilizing it even more, but at ortho position it might be creating a problem, creation of diazo. Although OCO-CH3 is electron donating substituent, but it's present in meta position, hence it will not significant effect on stability. The increase one should be So guys, in order of undergoing this mechanism, we'll find that reaction intermediate as a benzene diazonium ion is formed, and the more and more is the stability of that ion, higher is the rate of reaction towards diazotization. So R2 and Rn2 positive is never stable. Least reactivity is for A. Comparing these all three, this is the stability of Rn2, the benzene N2 positive will be there, and since this group is present at meta position, not having any electronic effect as such, this at ortho position will be having direct impact on the stability. D is somehow at lesser because of the this repulsive nature of this group. Sterically, this question was asked in JEE Main 2018 actually. So the correct answer should be A, D, B, C, right? Move forward here. We have a question that coupling of benzene diazonium with one naphthol will give you what? So naphthol is this compound, everyone. So now we have to find out that what will be the final product if you make this compound reaction with diazonium, benzene diazonium chloride. So this will behave as a electrophile and will attack on the para position, I guess mostly on para. So para substituted product should be there like this, one OH there, and then here will be the product, that N double bond N single benzene like this. Then it will become what? This is the product we got. So I guess this is C, right? This is C. C is correct. That is it all about diazo compounds, and just please go through the notes once again. try to make short notes out of this entire lecture and then get the confidence and about this topic. Now I'll take you to tests of amine. Where can you determine primary, secondary, aliphatic, aromatic amines? So we have first reaction called as Hinsberg reagent, which is benzene sulfonyl chloride. That is, this is your benzene with sulfonyl chloride. This is your compound, benzene sulfonyl chloride. So it's not sulfonyl chloride. So it can react with primary and secondary, but tertiary cannot react with this. And Hinsberg can this reagent can be used to detect the primary, secondary, and tertiary mostly. So what happens in case of primary amines? Primary amines has removable hydrogen. HCl is eliminated out. This compound will be formed. NH with a positive charge, and no, where is the Cl here? Okay, HCl is already removed. 1H from hydrogen, 1 chlorine over here, it been eliminated out. It will give you N-ethyl benzene sulfonamide. This sulfonamide reacts with another equivalent of base, and because of presence of this acidic hydrogen, it is dissolved in alkali, and it dissolves in alkali, and that is the confirmatory test with the primary amine. We have secondary amine also with us. On reaction of secondary amine with benzene sulfonyl chloride, the product will be NN diethyl benzene sulfonamide, which doesn't have acidic hydrogen, no acidic hydrogen present on nitrogen. So basically no, like, doesn't get dissolved, no dissolution in alkali. So if you add alkali over here, it will not get dissolved. This is insoluble in alkali. And tertiary amine do not give any kind of reaction. Tertiary amines don't give either of the reaction. So that is the test called as Hinsberg reagent test. Then number 2 test is called as reaction with nitrous acid. Nitrous acid mostly creates compound NO, nitroso compound, and nitroso positive. So basically it will give you to the rise of let's see. So nitrous acid is used to distinguish between primary, secondary, and tertiary amine. This reaction is carried out in situ, like in between the molecule from a mineral acid, sodium nitrite. Primary aliphatic amines only give this test nitrous acid to form aliphatic diazonium salt. Diazonium salt is unstable, liberate hydrogen gas and alcohol. Nitrogen gas and alcohol, okay, like this. Secondary amine do not react with, also react with nitrous acid to form the nitroso amine. So they will give you a nitroso compound instead of nitro N2 positive Cl minus. And tertiary amine, with this they form the nitrite salt, which are soluble in water, like that, R3NH NO2 minus. On heating they also give you alcohol and nitroso amine. So this is the test that is for primary, secondary, and tertiary. All three react in different type of reaction and producing the respective product. We have next called as Hoffmann muster test, in which we are going to make it reacted with CH2, carbon disulfide. So carbon disulfide on reaction with, the reaction is again the very similar. It forms S minus, so it will give you what? C double bond S, SH. This is like alkyl diathonic carbamic acid, and there is NHR or AR, whatever the group is there. Then it is reacted with HgCl2. It reacts with sulfur to form what? Black precipitate of mercuric sulfide, and the product will be RNCS, which is isothiocyanate, which has mustard like smell, mustard oil smell. That's what is said, mustard oil test. If we do the same thing in secondary, we will be getting a product, a compound like this, which doesn't react with HgCl2 and doesn't give any kind of product, no reaction. And tertiary do not react even with the carbon disulfide. These three were, sorry, the fourth test is carbylamine test. The fourth reaction is carbylamine reaction. Carbylamine reaction are the isocyanides, so they are formed as a product, and they have a very, what should I say it, foul smell, and that is the only test of their identification. So only primary amines give the test, let it be aromatic or let it be aliphatic, both of them give this test. So what actually happens this test? Chloroform and KOH. We use basic medium chloroform KOH. No doubt it forms what? Carbylamine reaction we studied a bit earlier. This reacts upon, this gives you a CCl2 dichlorocarbene as an electrophile, attacks over there, forming and compound which is RNCCl2. N having a negative charge, Cl with a positive charge, Cl with a negative charge, N with a positive charge, being attacked by, then later on it is being attacked by the hydrolysis and forms what? RNC, which is called as the alkyl isonitrile. But who doesn't give this reaction? Secondary doesn't give this reaction. Secondary also gives this reaction, right? Carbylamine. No. Secondary doesn't give this reaction. Only primary gives this reaction. A primary amine is heated with CS2 in presence of excess of Hg2Cl2 gives isothiocyanate. The reaction is called as what? Mustard oil reaction. Hoffmann mustard oil reaction. A compound which on reaction with aqueous nitrous acid gives oily nitrosoamine. Oily nitrosoamine. Compound which on reaction with nitrous acid. So it's the only primary amine only gives this answer, right? No. With aqueous nitrous acid gives an oily nitrosoamine. So diethylamine. Secondary gives this reaction of nitroso. Primary to makes the do you know what does primary amine make? Primary amine makes the alkyl diazonium salt, and which are unstable in presence of water, they produce alcohol. So only secondary, right? This only 2 degree reacts with it to form it, and 2 degree answer is diethylamine. What are the uses of amines? Amines are very good reagents making the azo dyes, as we just have studied, and also in nylon formation, and some medicines and drugs also we use it. There are like wide uses of developing chemicals for using this, and for crop protection, medications and water purification. They also have some uses in the production of the personal care, cosmetics, stuff like that. Hinsberg reagent is benzene sulfonyl chloride, SO2Cl2. We have the next question here. Organic compound A treated with benzene sulfonyl chloride and B is soluble in NaOH. So A is what? A should be what? 1 degree amine, because it's soluble also. So where can you find 1 degree? Nowhere. Okay, here it is 1 degree. C. Carbylamine test is used to detect the presence of primary amino group in the organic compound. Which of the following compound is formed when this test is performed with aniline? If aniline performed this test, then NC will be formed. Benzene isocyanide, or we can call it carbylamine. Guys, this question was asked in this year itself, 2024. The question is very simple. No, not the past year actually. Right now we are in 2025. The number of compound which will give you the reaction with Hinsberg reagent. So we all know that 1 degree and 2 degree can give this test. So where can you find 1 degree and 2 degree? So this is azo. This is what? Amide. This is what? 1 degree aromatic. This is what? 3 degree. No. This is what? 2 degree. Yes. This is 3 degree. No. This is 1 degree. Yes. This is 2 degree. Yes. This is no. This is 1 degree. Yes. And this is also amide. So no. So correct answer should be what? 1, 2, 3, 4, 5. I think 5 should be the correct answer. Can we check? 5 is the correct answer. And guys, that's it for the day. We had an amazing session today. Hopefully I went a bit fast because I know that your exams are quite nearby, and I wanted all of you to just quickly review this chapter, learn all the reactions. Now make short notes and don't run behind the mechanism unless your JEE Main exam is getting over. Then after that you can apply going through all the reaction mechanism and can find out your way towards advanced. Until then it's not required to make sure all the mains reaction.